Okay, this is a video key for the review. So it says, be prepared to give exact, simplified, and or decimal approximation answers when requested. So be sure to do that. And remember, in terms of pi, it's just multiplying everything you can except for multiplying by pi and just putting pi at the end to show that it's times pi. Okay, so number one, a circle's circumference is 16 pi feet. Find its diameter. Okay, so we know that the circumference is equal to, and you can use any of the formulas, but the easiest one to do here is pi d or d pi. Okay, so we know that the circumference is 16 pi and the diameter, and that's equal to the diameter times pi. So obviously we divide each side by pi, or just see that the diameter is 16 feet. Labels 16 feet. And that's it for number one. Number two, a circle's circumference is 20 pi feet. Find its radius. Same thing. So obviously we can see that that means that the diameter is 20, and so half of that would be the radius. So the radius is 10 feet. Labels 10 feet. Okay, moving on. Based on the figure to the right, find the correct match. You may only use a letter once, or matching, okay? So the radius, we can see KA would be a radius, or KG would be a radius. So let's look for KG. JB would be a diameter. So let's do that first. So JB is a diameter. That's going to be the second one. So that's C. JB is the diameter. A chord. So there's lots of chords, but AC is a chord. Really, JB is a chord too, but it's also diameter, so that's a more specific one. So AC is our chord. So line segment AC. Remember, chords and diameters and radii are segments. Minor arc. Okay, so remember, minor arcs are named by two letters. Okay, so like JG would work. Is that an option? Nope. But like JCB wouldn't work because that'd be JCB. That's a major arc because it's named with three letters. So it can only be named with two letters. So GA, there you go. GA would be a minor arc. So E. And then a semicircle, okay, that would be, we have to have two endpoints that form a diameter. So J and B form a diameter, so we need J and B. Here's one with J and B, C in the middle, JCB. That would be our semicircle. And again, it's because the endpoints of that arc form a diameter, okay? Those two, if you connect them, that's a diameter of the circle. And it has to be named with three letters. A central angle, so angle AKJ, or AKG, let's look, AKG, that is a central angle because the vertex of the angle, which will always be the middle one, where to go, that is the center of the circle, so that would be K. And then name of the circle is K, so circle K would be F. All right, let's go back to the radius. I'm not sure why okay, KA right here. KA is the radius. Okay, so that works for number three. Okay, moving on. Find the radius, diameter, and circumference of the circle. So we're given an inscribed figure. We're given a triangle. So you're probably thinking, how in the world can we do this? Well, we can find out this length right here, which is a diameter because its endpoints are on the circle and it goes through the center. We can find it by using Pythagorean theorem because we've got a right triangle here, okay? So we can do 15 squared plus 8 squared equals C squared. So 225 plus 64 is equal to C squared. 225 plus 64 is 289, and yes, that is a perfect square. Its square root is 17. So C is equal to 17. So we know that the diameter is 17, and then we can use that to answer the rest of the question. So, okay, that's a little c, okay? It's not a capital C for circumference, okay? So we said the diameter is 17. The radius would be half of that, so that's 8.5. And the circumference would be, let's put it in terms of pi and give a decimal approximation. So it's diameter times pi, so 17 pi, or if we put that on our calculator, we get about 53.4, approximately 53.4. And it's just units because we were not given a unit of measurement. All right, last part here on the first page. So find the following measures. So find x. Okay, so notice we've got some measurements here. These are not arc length because it has the degrees. So we're actually talking about the measure of the arc. So we're talking about the central angle here. And notice that we've got lines BD and CE, okay? And since they go through the circle, we know that CE is a diameter and BD is a diameter. But the most important thing here is that because we have two lines that intersect, we've got vertical angles that are formed. So that means that these two angle measures, these two arc measures, are equal. So we know that 6x is equal to 2x plus 12. Oops. And we can solve this. It's not hard to solve. Okay, minus 2x minus 2x. 4x equals 12 divided by 4. And x equals 3. So that's our first answer. Now we want to find the measure of arc BE. So again, that's the central angle measure. So BE is this guy right here. So in order to find that guy, we actually need to find this one first. So to find the measure of arc BC, that's going to be equal to 6 times what we found for x, which is 3. So the measure of arc length BC is 18. 6 times 3. And so that means this one is 18 as well. So we've got 18 degrees and 18 degrees. And again, since we have vertical angles, we know these two are equal as well. So I know I have 18 times 2 will give me 36 degrees total that I know about. And so I'm going to do 360 minus 36, divide that by 2 to get the remaining two measures here. So 360 minus 36 gives us 324, divide that by 2, and we get 162. So these arc measures are each 162. So 162 degrees. So BE, 162 degrees. ED, okay, that is another, these are both minor arcs, so ED is going to be the smaller between the two. So that's 18 degrees, just like BC. And then CBE is a major arc, so starting from C to B to E. And that's actually going to be a semicircle since C and E are the endpoints of a diameter. And so we're just going to add together the two angle measures. So it's 18 plus 162, which is 180. And that makes sense because it's a semicircle and that will be half of the circle. So that's a way you can also check your answer there. That's it for the first page. For the second page, find the length of the arc AB if the radius is 24 centimeters. Okay, so we've got the arc length formula, so it's going to be the fraction of the circle. So since this arc measure is 60 degrees, you do the arc measure divided by 360 to see what fraction of the circle that is, and that's obviously a sixth of the circle, multiplied by the circumference. So the radius is 24, so we know it's going to be 2 times pi times the radius of 24. So L is equal to, well, I'm not going to write L again. So that reduces to 1/6 times, I'm going to go ahead and multiply 2 times 24 to give me 48 pi. Then I'll multiply 1/6 and 48, which is 8. So our answer is 8 pi. So that is the measure of arc length AB. So that's 8 pi. And then approximately, so I want you, like I said, I want you to do both. So put 8 pi in the calculator. And you guys should know not to use 3.14. Use exact pi. And this would be 8 pi centimeters or 25.13 centimeters. And that's approximately, so please use the approximation sign like I didn't do. Okay, approximately. Okay, so exact answer is 8 pi. Approximation is 25.13. All right, the second one is pretty much the same thing. So we have a sixth of the circle again, and we're finding the radius of the circle if arc AB has a length of 4 pi feet. So I already know the arc length. So that's 4 pi feet. Okay, so I know that 4 pi came from a sixth of the circle. Okay, and let's go ahead and just do times 2 pi r because we're solving for radius. So we know that to find that arc length, we would have taken the fraction of the circle it is, so 60, which is the central angle of the arc we're talking about, or the arc measure, and divided by the total degrees in a circle, 360, times the circumference, 2 pi r. So now we can solve. We know that since pi is on both sides, we can easily divide by both sides by pi to get rid of it. And so we're left with 4 equals, and I'm going to go ahead and multiply 1/6 times 2 to get 1/3. So 1/3 r. And then we just solve from there. So to get rid of the 1/3, I can either divide by 1/3 or multiply by 3, which is way easier. So the r is equal to 12. So that means our radius, and we have to have a label here, is 12 feet. So the radius of a circle that has a 1/6 of it have an arc length of 4 pi, then its radius will be 12 feet. The next one, we are given the arc length again, and so we're trying to find the measure of angle ACB if the diameter is 15. So this first one, we were trying to solve for the arc length given the fraction of the circle and some piece of information to find circumference. On number 13, we were given the arc length given the portion of the circle, and we were asked to find the radius of the circle. So we had to kind of find circumference in that to find radius. And then this last one, we're finding a different piece of information again. We're finding the central angle measure given the arc length and given enough information to find the circumference. So in order to find that angle measure, we know that the arc length is 10.6, and that came from some fraction of the circle, so x over 360, because we know, so this is going to be x is our x degrees is what we're trying to figure out. We would divide that by 360 to get the fraction of the circle that we're talking about, multiplied by the diameter, and in this case we're going to do diameter as pi times d, so pi times 15, since I know the diameter is 15. And then we just have to solve it from there. So there's lots of different ways you can go about this, but I'm going to go ahead and say 10.6 equals, and then I'm going to do some reducing on here. So divide each by 15. So 360 divided by 15 is 24. So that goes in my denominator. So I'll have x pi over 24. And then I'm trying to get x by itself, so I'm just going to multiply by 24 over pi. Multiply by 24 over pi, because that'll cancel out the 24 and the pi on this side, so we're left with x. So x is equal to, and I'm going to go ahead and for the exact answer, we are going to, actually I don't want an exact answer here, because it's got pi and we're looking for an angle. So we do 24 times 10.6, and then we're going to, which is 254.4, and divide that by pi. We get 80.978. So if we round to the nearest, let's round to the nearest degree here. So that'd be 81 degrees. So like the 10.6, we could have, if rounded to get that one. So we're going to round to get to the nearest degree here. And I'll let you know on the test or the quiz what you're supposed to round to. Okay, last one. A 2 foot by 3 foot rectangular poster fits perfectly on a circular table. What is the circumference of the table? Okay, so we need some piece of information to help us find circumference. Since each of the vertices of the rectangle lie in the circle, we can easily connect 2 of them through the center to form a diameter, and we can find that out. So it's 2 by 3 foot, so this would be 2 and 3, and we can use Pythagorean theorem to find the diameter. So we're going to do 3 squared plus 2 squared equals c squared. So that's 9 plus 4 equals c squared. So that's the square root of 13 is equal to c. So that's actually our diameter. So I'm going to say the diameter is equal to the square root of 13. And then to find the circumference, we know that circumference is equal to pi d. So circumference is equal to square root of 13, or we always put numbers first. So it's a little tricky here when we have square roots and pi, because pi is always last and square roots are always last when you're talking about multiplying them by numbers. But in this case, a pi will go first. So pi times the square root of 13. And that is strange because we're always used to having pi last. But again, the reason we don't usually put anything after the square root is because we're not sure just by handwriting if it belongs underneath the square root or not. So it's always put in front. So put that pi in front if you've got a square root that you're multiplying it by as well, or any radical. And I need to put a label. So feet, that is the exact answer. And we can get our irrational approximation here. So they're both irrational numbers. So square root of 13 times pi is equal to about, approximately 11.3. Let's go to the hundredths place. 33 feet. So that's our approximation and the exact, and I want both of those. And that's it for the review.